Hello everybody, my name is Maxim, and I'm going to talk about LEDGE reference platform, and presentation name is LEDGE RP bootstrap, and today I was asked two main questions. First question is what is age, and the second question was what is bootstrap. And actually bootstrap, it's an interesting word because it has a bunch of different meaning. Depends on which area you are working. If you are electric engineer, for example, bootstrap will be how you pile pins on the chip and what initial configuration will be on power up. If you do HTML, bootstrap is a common framework to do some experiments and quickly to do website. And if you're working with Linux kernel, probably bootstrap will be some protocol from bootloader to the kernel. So my presentation is to say about our reference platform, which we did, and point to the links how to compile it and run it on real hardware or not real hardware, and links to our build system and test system. So question about what is age. I drew this simple picture. There is some end devices and the cloud, and between the devices and the cloud there are some gateways. And age means that there is no simple gateway which will just forward your traffic to the cloud and back. So you can offload some activity from the end device to the gateway, and a gateway will be your edge device, and that means that this edge device will have a lot of smart things to do, and common requirements will be security. If you send some data to be computed on the edge node, then you should be able you should be sure that the data will be secure and it was not hacked. So the common edge hot topics are offload data to the edge node and provide high-level security, do secure updates of edge node and maintains of that edge node, and use fast boot for edge node, and so on. So in Linaro, when we talk about LEDGE reference platform, we created three different flavors of reference platform. One is based on OpenEmbedded, one is on Debian, and one is based on Fedora IoT. They all have the same feature set, the same packages. They work almost the same. When I talk about features, and I'm talking about the SE Linux for security, OS 3, UEFI. We use mainline kernel. We use cloud tools, and we use FTPM for ST board. To build OpenEmbedded reference platform, you can use link from this presentation, from this link, and it has a README file with all instructions which you need, how to clone a repository, specify target machine, and to build it. And in a single command, you can bring up QEMU, a service, with image which you just built, and run a virtual machine with all built artifacts. OpenEmbedded supports different targets like QEMU, ARM, and ARM64. as well as x86, STM board, and Synthesizer and TI boards. You can use follow link if you have Linara account to download binaries, which we periodically upload to that location, to snapshots.linara.org. So build system just takes sources, and each day it builds and tests system and places binaries to that location. We use daily CI, which is triggered by Jenkins. So it's ci.linara.org. Job name is LEDGE OE. It's OpenEmbedded, so it does source code checkout and build images for all machines and place it to snapshot.linara.org. And after that, it will run corresponding Lava job. Lava is a Linara framework for autonomous testing. And it will run this image on virtual or real machines. And you can use the jobs as validation of the build and also as template to run your additional tests on the resulted images. Lava, if you want to modify something in Lava, you can use that URL, git.linara.org or git-us.linara.org. It actually points to the mirror of the server. For example, in Russia, git.linara.org is blocked, but git-us.linara.org can be used. And you can take a look at these files, LEDGE OE, LEDGE premerge, CI, and trigger daily build. So it's the files which run all compilation and tests. For Debian build, we also have the code placed on git.linara.org CI configs. We do ARM v7 and ARM v8 builds and also upload artifacts to snapshot.linara.org. For Debian, for now, we only build rootfs. We also are going to add build of kernels and UEFI firmware, so it will be a complete build. And Lava results for that image can be found on that links, Linara CI, ci.linara.org, job, LEDGE, and the name of Debian build. And to build the Debian, we use tool which is named FI. It's a full optimization installation. And we created a separate template and which calls FI disk image, and it just builds the final image. Template is, I also provided link where this template is placed, so everyone can send pull request to change it if needed. For Fedora IoT, so we have a Jenkins job, which the name is LEDGE Fedora IoT YAML. It runs periodically. It places it in configs.git. And this builds, this job also downloads sources from Fedora website, and install it for special target. And also we have snapshots and status page. To install Fedora IT on QEMU target, we use a tool virt install and initrd image and the kernel from I'm sorry, and then initrd image and the kernel from download fedoraproject.org, and we provide a file which describes installation. So it's a kickstart script which actually says which partition to use, how to split partition, which time zone to use, how to add users to sudoers. So we just provide this image, and at the result of the script will be installation for QEMU. So it will be an image which we can run, and the system will boot up. And also to make it work correctly, we just specify the latest EDK2 GFI images. Here. Run logs, link which shows the logs of our build system. Also, we installed Fedora IT on Synthesizer box, and there is an example of Lava task, how to make it happen. So actually we take for PXE Linux Linux kernel image, we take initrd, and also we provide kickstart file. And after that we boot the system and installation starts, and after install, target will reboot to install the Fedora IT image. There is an example link. If you want to use Lava and install Fedora IT on Synthesizer box, you can use that link.
Maxime, could I ask a question on the boot images? So you've talked about you're doing a separate image for each platform. What are the blockers for doing a generic image that would boot, like kernel user space, that would boot on all the platforms? Or are you using this common kernel?
Not a big blocker, right? For OpenEmbedded, it's from beginning. So actually, images are created for specific target because it has special compiler flags and there is no common platform. And for Fedora IT, they have single image, but it's single image for example, for all ARM v8, right? For the same devices, right? So they cannot split. Most difficult part is the booting. If machine is compliant with boot specification, then we can use it, right? If it needs some different partitions and to do initial boot up, to place U-boot images or EDK2 to different places, then probably we cannot create single image. So the idea is to came with single image for Debian and OpenEmbedded, for ARMv8 at least. Yeah, so we're still working on that, right?
That's what we do. We use the Fedora kernel because we can't change the Fedora kernel. So we pick up the main options, align them with the OpenEmbedded build, and since we can't use the Debian kernel because it doesn't have all the upstream support we need yet, we pick up the OpenEmbedded image, align it to Fedora, build that, and we use it for OpenEmbedded and Debian. Now the reason we're not using a single kernel yet is that we have a requirement about boot times. So you have to make sure that the device is booting really fast, which means you have to kick out some modules. But the idea is that we're going to convert every driver that we don't need into a module, and we're going to have a single image as well for the kernel.
So have you taken steps to actually include the features that are missing from the Debian kernel to Debian? So it's in your roadmap?
But I think that is important, though, for it to be priority to get the common kernel. And if you've got board-specific builds, make sure that those are listed as secondary, right? The messaging needs to be primary is common kernel, and then if you do have to do custom stuff, then
the
you go
idea.
up to the
Common kernel mainline, unless there's not support for the vendors, which we use whatever they provide. But the goal is to upstream everything eventually.
Thank you.
So there's things which we are working on. It's firmware TPM support, UEFI support based on Tiana Core and U-boot. Integrity, it's EMI EVM support on OpenEmbedded and Debian. And actually there's also interesting situation that tools exists, but no common way to sign applications. And kernel modulus signing and SE Linux support. And we want to make SE Linux support probably in the same way as Fedora has with the same policies. And task, it's what I said a little bit before, and what we were trying to align package list with Fedora IT for both Debian and OpenEmbedded. We are trying to improve our validation system based on Lava to add more targets and run complete tests, and we want to run the test which Linara already has, like kernel tests. Next task is Opti. It's virtualization support for FTPM and PKS. Support of boot specification SBSI for QEMU. We want single image to run in virtual targets. So because we found it very useful, then people can do some prototypes without a real hardware and just use single image for QEMU, and after that switch to a real machine. OTA updates to do updates securely, and I found common way to update everything, including firmware, application, and whatever. Huge task is application isolation, so it might be a container and hypervisor. So we're thinking which hypervisor is better for age and what are requirements and how to use it, TSN, and so on. There is our email. It's teamledge@linara.org. So if somebody wants to join to Ledge team, please send us a mail. And if you have some ideas or if you want to work on some targets, please contact us. That's all for my presentation. If anybody has questions.
Thank you. What's TSN on your last slide?
It's a time-sensitive network, so it's hardware shapers and Linux offload to hardware shapers.
You've mentioned FTPM over there. So are you planning to emulate a TPM device on Opti? Is that what you're planning to do?
Yeah. I think Ilyas can explain more, right?
We have an implementation on firmware TPM on an SD board, which is an ARMv7 which works. So we run the firmware TPM on the secure world, and we've helped on the upstream on the kernel driver for the non-secure world. And yes, it's 2.0. We plan on running a TPM test suite on it at some point, but there's There's some drawbacks on using the firmware TPM, which we're working on, like you can't use it until you have a Linux running on the specific device, because there's no backing storage on the secure world for it. So depending on the devices we get, we plan on having more support for.
Are there plans to kind of take the support from Linux, because currently you would be depending on a lot of stuff on Linux for getting this TPM running. So on plans to take it to the bootloader or the firmware level?
We had some discussion, but this is a substantial amount of engineering work, and we hope we get some resources to do that.
Okay.
But
this is definitely not the only firmware TPM activity that's going on. ARM is doing some firmware TPM investigation internally. So, I mean, we're certainly working with Ledge to make sure that we're not going off in different directions. If you want specific names, I can come talk to me and I can put you in contact with people.
So, I mean, currently on ARM v8.0, if kind of I need to run an Opti OS along with maybe a secure UEFI if you need to run. So is that also there in the charter where when you're talking about the secure boot part?
all right. Yep. The other part we're working on is that the existing implementation on storing UEFI secure variables from EDK2 is called standalone MM, and it runs on Secure Payload Manager. And the problem with the Secure Payload Manager, for us at least, is that it doesn't work on ARMv7. And since we need firmware TPM, we can't run an SPM payload with the Opti payload and Opti as well. So what we're working on right now is having some kind of ETA that will enable secure variable storage just by using Opti.
On Opti itself?
Yes.
So this would work on an ARM v8.0 platform?
Yes, and an ARMv7.
Do you plan to add more Linux distribution to your tests?
Distribution, I think it's not a requirement now, but everything depends on the members.
If a distro comes and wants to do it. So with the reference platforms, it's come from the steering committee demand, and so Fedora has stepped up and said they want to do that. Debian's important because it's a community distro. Yocto is important because it's got lots of community support. Any other distros would require a sponsor to step up and say, hey, this needs to happen.
Yeah.
And what are the plans for the OTA? So you mentioned OTA over there. So different platforms kind of have different boot sources, boot flows and stuff. So how do you plan to kind of standardize the OTA flow? Any plans to have something in the firmware ATF or something which is running on a V8 platform?
Okay, we haven't still decided on how we want to do over-the-air upgrades. The only thing we're trying to make sure at the moment is that we include OS3 support on the Debian and OpenEmbedded platform and the RPM OS3, which comes with the Fedora IoT. So that's we don't have anything specific in mind at the moment. We're just making sure that the tools you'll need are there.
Finally, it will have to be tied up with
Yes.
the platform and
Yes.
the security infrastructure.
That's very much an open question. Thanks to use the microphone. The update story is very much an open question on what does it look like for all of the firmware layers, and how those pieces get updated and securely, and what the cycle is. So that's I don't think we've really dug into that yet. Another area of work that needs to be done is device onboarding. Right. So what does it look like? You got a device out in the field. What does it look like to test that it's actually the device you think it is and onboard it, and what you need to do to manage it, right? So those are very much open questions. I would really like to see that part of the reference platform, have all those things implemented and how to do them, but we've got to work out what that looks like.
Okay, thank you.